A place with oceans, clouds, blue sky, and maybe even life. Could Earth 2.0 really exist? And if it does, what would it actually be like? For centuries, humans have gazed up at the stars, asking one simple question: are we alone? As technology advanced, so did our curiosity, and now, for the first time in human history, we're getting close to finding answers. But in recent years, the question evolved into something even bigger. Something more urgent. Is there another Earth? In 2009, NASA sent the Kepler Space Telescope on its way in search of planets beyond our solar system, ones that could host life. Now fast forward to today and we have found thousands of planets orbiting around other stars. Some of them, situated in their star's so-called habitable zone, have even been given names like Earth 2.0. But what, exactly, is Earth 2.0? What do the scientists look for on a planet that will define it as a twin to our own? It just so happens that finding a new Earth isn't quite as simple as finding just any planet. And Earth 2.0 actually needs to check a number of very particular boxes if it's going to make the grade. First on the list, size. Earth 2.0 needs to be roughly the size of our planet. Too large, and its gravity could make it inhospitable for life as we know it. Too small, and it might not have an atmosphere to hold on to. Location. Next up. The planet has got to be in the so-called Goldilocks zone, not too hot, not too cold, but just right. That puts it at just the right distance from its star where liquid water might be present on the surface. But size and location are not enough. For life to take hold, a planet also requires an atmosphere thick enough to shield it from solar radiation and strong enough to produce weather patterns, like Earth's oceans and clouds. Finally, Earth 2.0 must possess water. The presence of liquid water is one of the most significant factors in the search for life. Life as we know it would simply not exist without it. So where does that leave us today? Thanks to the Kepler Space Telescope, astronomers have identified more than 2,600 confirmed exoplanets. But not all of them are wannabe Earths. Only a handful fit the bill. Take, for instance, Kepler 452b, probably one of the most renowned Earth-like planets to have been discovered to date. It is 1,400 light-years away and sits in the habitable zone of its star. But here's the catch: it's 60% bigger than Earth, and its sun is much older, meaning its environment might be quite unlike that of our own. Then there's Proxima b, circling the star closest to our own, Proxima Centauri. It's within its Goldilocks zone and, at just more than 4 light-years away, it is practically our neighbor. However, Proxima b's star is a so-called red dwarf star, meaning it could be bathed in lethal solar flares that make life very difficult. Even though these planets are really exciting, they're still far from perfect Earth clones. Each has its own challenges, whether that means extreme weather, radiation, or a wildly different atmosphere. But the hunt for Earth 2.0 is far from over. In truth, it's just getting going. With the launch of the James Webb Space Telescope, astronomers finally have an even more powerful tool to peer into the atmospheres of distant worlds. This telescope will help us detect signs of life, things like oxygen, methane, and other gases in an exoplanet's atmosphere. It's a game changer. For the first time, we might be able to tell if a distant planet could truly support life. Here's the surprising truth. Even if we do find a planet with oceans, an atmosphere, and all the right ingredients for life, there's a good chance it won't be anything like Earth. For one thing, many of these planets orbit stars much different from our Sun. Red dwarf stars, for example, are smaller and cooler but far more active, often unleashing violent flares. Planets around these stars might be tidally locked. In other words, one side faces eternal daylight, while the other side is in perpetual darkness. And while liquid water is key to life, it could exist under very different conditions than on Earth, like in subsurface oceans hidden beneath thick ice. It's easy to take for granted just how special Earth is. Everything here is perfectly balanced, from our distance from the Sun to our stable climate, from our atmosphere to our protective magnetic field. Our planet is not just any planet. It's a complex system, delicately tuned to support life. While we may one day find Earth 2.0, it might be centuries before we find anything truly like home. Yet, the search for Earth 2.0 can be greater than finding a new home. It is about limits on human knowledge, asking questions larger than ourselves, and seeking the very fabric of the universe. With every exoplanet that we discover, we learn more about just how rare and precious life is, and that in the grand scheme of the universe, Earth was a tiny miracle. The quest for Earth 2.0 is far from over. With new discoveries being made every day, with the power of modern telescopes, not to mention future technologies, who knows what we'll find next? Maybe, just maybe, there's another Earth out there waiting for us. And when we find it, we will have taken one of the greatest steps in the history of exploration. We often refer to seeking out planets that are habitable, but what does that really mean? Would it be enough that a planet simply have water and an atmosphere, or would the conditions have to be just right, as they are here on Earth, for life to really flourish? On Earth, life is resilient. We have found organisms living in places most inhospitable, deep under the ocean, in volcanic vents, even in frozen glaciers. But would life as we know it survive in Earth 2.0? Or would life there be something completely alien? Imagine, if you will, that we really do find life on Earth 2.0. What would that life look like? Would it be in the form of plants and animals, as we know on Earth, or would it be far more exotic? Life on Earth evolved to adapt to its environment. The same would be true for life on Earth 2.0. All of the planet's size, gravity, atmosphere, and distance from its star would help mold how its organisms evolve. For example, on a world with a high G, one might think that the animals would be squatter or even burrowing near the surface. On a low G planet, life can stretch to the heavens as animals easily glide through tenuous air. Let us now focus on some of the exoplanets that have gained the attention of scientists in the search for Earth 2.0. None of these planets are precisely like Earth, but each one of them has tantalizing potential to be a habitable world. First up, Kepler-22b. Discovered in 2011, Kepler-22b was one of the first Earth-like planets found in the habitable zone of its star. It's 2.4 times the size of Earth, meaning it's a super-Earth, a class of planet that's larger but perhaps still rocky. Kepler-22b can have vast oceans. We do not know if it has a solid surface yet. Its atmosphere is a mystery, but it's one of the closest matches to an Earth-like planet we have found so far. Coming next is Proxima b. This rocky world orbits the red dwarf star Proxima Centauri. The nearest star to our own sun lies a little more than 4 light-years from our planet. In fact, it resides well within the habitable zone, though it may be subject to strong solar flares because of how close it is to its star. These flares could strip the planet's atmosphere over time, making it unlikely that life would be able to survive. But it's still possible that Proxima b has a protective magnetic field, just like Earth, that shields it from these intense blasts of radiation. Finally, we have TRAPPIST-1e. It was discovered in the year 2017. It's one of 7 rocky planets orbiting the same ultra-cool dwarf star. 3 such planets out of these 7, to be precise, including TRAPPIST-1e, are in the habitable zone where liquid water could exist. Whereas TRAPPIST-1e is roughly Earth-sized and might have a rocky surface, that surface might be covered in oceans. But because it orbits so close to its star, it's probably tidally locked, with one side bathed in perpetual daylight, the other in endless darkness. Life here, if life exists, would have to adapt to some pretty extreme conditions. The most interesting types of exoplanets, sometimes dubbed as the potential Earth 2.0s, are known as super-Earths. These planets are much bigger than Earth, oftentimes up to 10 times the mass, yet still possess a solid surface, unlike gas giants such as Jupiter. Super-Earths are somewhat enigmatic. Due to their size, they could have thicker atmospheres, a stronger magnetic field, and more stable climates. On the other hand, due to the stronger gravity, life could find it harder to move its limbs and adapt. Some scientists believe that super-Earths might actually be better for life than planets just like Earth. They might hang on to more of their atmosphere, have more abundant resources, and suffer fewer wild climate oscillations. But take it a step further. Imagine we do find Earth 2.0, an Earth-like planet, with liquid water, a breathable atmosphere, and at just the right temperature for humans to survive there. What would that take for us to live on it? Initially, humans would have to stay in artificial habitats, just as we do in the case of Mars, in order to protect ourselves from any sort of entity which we do not know may hurt us. Whether new bacteria or alien wildlife or toxic chemicals in the atmosphere. We need to study the environment carefully and build up sustainable ecosystems and then gradually adapt to our new home. In the long run, we can even terraform the planet, molding it into an Earth-like one. That process can take centuries or even longer. The thing is, as cool as finding an Earth 2.0 might sound, actually making it a place we could set our feet on is a totally different matter. With that said, thanks for watching and until next time.